Greetings, Living Environment students. It's Mr. Gopal, and I'm back with another lesson from Unit 4 on homeostasis and immunity. We've already discussed how the immune system adapts to viruses and how we can use vaccines also to prepare our body to face a deadly virus. Now we want to talk about how the body deals with bacterial infections, but more specifically, how scientists have created a resource for us to resist bacterial infection and stop it in its tracks. And those things are called antibiotics. So the lesson specifically is antibiotics and antibiotic resistance. We want to know what antibiotics are, how they can be used to help the immune system fight off a bacterial infection, and then what is antibiotic resistance, and how is bacteria's ability to evolve antibiotic resistance influenced our use of antibiotics. First things first, we want to talk about how a bacteria cell replicates and how antibiotics prevent that from happening. How it replicates normally is by copying its DNA and then dividing. So it's got an extra copy and it divides in half, all right, and then it passes on the new copy of the DNA into that new cell, all right. A bacterial cell, generally speaking, it will have a cell wall, but it won't really have organelles besides its ribosomes. And so antibiotics work to disrupt the creation of a cell wall or disrupt this process of replicating the DNA. And so it'll inhibit protein synthesis or the replication itself. How can we tell it's working? Well, scientists often grow bacteria in a petri dish and test different possible antibiotics on it. You can see in both of these images, one of E. coli and the other of B. subtilis, that the antibiotic on the right-hand side of the divided petri dish has been far more effective. How can I tell visually? Because the one on the left-hand side has grown much farther out in a ring around its original location. So that bacteria is replicated far more than the bacteria on the right. So we know that the antibiotics used on the right-hand side are far more effective than those used on the left. And so I've created my usual resource for this. We have our definitions of bacteria and antibiotics that I've already discussed. You can go here to review the key concepts about not only how bacterial cells are prevented from growing by antibiotics, but also how we test antibiotics and then why we shouldn't overuse them. And the basic reason behind why we shouldn't overuse them is that bacteria is kind of smart in a way. It will develop resistance. And that brings me into the vocabulary section. We already know what reproduction is, and I've already talked about how it works specifically with bacteria, but we need to discuss mutation. Bacteria multiplies so rapidly, all right, that it will continually create new versions of itself. We call these new versions mutations. And just because a certain antibiotic is effective in treating bacteria does not mean that it's effective against all of its possible mutations. And so when an antibiotic stops becoming effective against all possible mutations of bacteria, that means the bacteria has developed what we call resistance. It will be harder to stop because there's something new and unique about the new combinations of DNA from certain copies of bacteria, and it will continue to multiply and it will continue to make us sick. So all of this goes into understanding how to tackle these Regents problems, right? I'm gonna move this a little bit just so that is together with the rest of it. And so down here, I give a hint for each of your problems. The first one is a typical Regents problem where we see petri dishes with bacteria growing. We already discussed that concept in there, just to remind you, and I don't think I used the vocabulary word, but zone of inhibition is what they call the ring that forms where bacteria grows until it stops growing. That means when it stops growing, that means that it's been inhibited, and the earlier it stops growing means relates to how effective that particular antibiotic is in killing bacteria. Okay, so the smaller the ring, the more effective the antibiotic, and the more useful the test. And so we can see here, we've got 4 different choices about what exactly is being represented and demonstrated by these petri dishes. Well, actually, it's a before and after the petri dish. All right. And we want to think about what scientists did or how they used petri dishes to determine the efficacy of a certain antibiotic. Now down here, I'm going to elaborate on this a little bit because I didn't talk about it too much before. We've got a paragraph about another way to kill certain bacteria, all right? And so we can heat them up and they will die very often, okay? And so these possible electric heaters might be another way that's not an antibiotic to kill bacteria. In order to determine what the long-term benefit is using these heaters over antibiotics actually is, we need to think about overuse of antibiotics, how that can be a dangerous form of treatment in the long run. All right. So you've got here my resource, ground floor definitions, key concepts, important vocabulary, and my usual Regents tips and tricks, which I'll close with. You want to underline the question and box any important science vocabulary that you see, and then use those things to eliminate any extra information that is not important to the question. When you solve a multiple choice question, cross out your obviously wrong answers first. If you need to, turn back to your notes, like right here, you can just scroll up and then go back down to the problems that are in the lesson. Always bring detailed questions to your teachers afterwards, but do keep these hints and these definitions and concepts in mind as you tackle the Regents problems. I want to wish you good luck, and I hope to see you soon.